Hello, Ms. Treadway here. We are starting our 2.4 notes, and we are going to be talking about another type of proofs. So we talked about paragraph proofs previously, and now we are going to get into what are called two-column proofs. So before we do that, talk about some little housekeeping things, some definitions. Starting with proofs themselves, the definition of a proof is a series of logical statements, each statement helping to prove an idea being backed by a given, definition, property, postulate, or theorem. Okay? And then the given is the info given to help you prove a statement, the if part of a conditional statement. And then proving, what you're proving is what you're asked to show using the givens and reasons, the then part of the conditional statement. So thinking back to conditional statements and logic that we learned, the given is what comes after the if, and what you're proving comes after the then. So before we get into some examples, we need to talk about some properties that we're going to be using in our algebraic proofs. So we are going to be using all of these properties in our proofs and examples today. So let's start with reflexive. Everything is equal to itself. So for example, I could say A is equal to A, or 7 is equal to 7. Reflexive, everything is equal to itself. Okay. Then symmetric, equal quantities remain equal when switched. So I could say A is equal to B, or I could say B is equal to A. They are still equal. Next, I have transitive, and this is the transfer of equity. An entire side is placed. And what that means is if I'm told that A is equal to C and B is equal to C, then I can use the transitive property to conclude that A is also equal to B. So an entire side was replaced. Next, we move into substitution, and that's saying if two quantities are equal, you can replace one with the other in an expression or equation. So for example, if I'm told that A is equal to B, and I'm given the equation C is equal to A plus 10, I can rewrite that equation as C is equal to B plus 10 because of substitution. Next, I have the distributive property. So I'm distributing a quantity, so if I have A times B plus C, I can rewrite that as AB plus AC. It distributes to what's inside of the parentheses. All right, now POE, these last three that we're talking about here have POE on them. And what that means, I'm sorry, there's a fourth one, there's one on the back side. But so when you say the word POE, what that means is property of equality. So when you see POE, that's what that means, property of equality. So starting with our addition POE, our addition property of equality, adding the same thing to both sides of an equation. So if I have A is equal to B, I can also add the same thing to both sides and it will stay equal. So A plus C is equal to B plus C because A is equal to B. So the same thing goes for my subtraction property of equality. If A is equal to B, I can say that A minus C is equal to B minus C. And then my multiplication property of equality, if A is equal to B, then A times C is equal to B times C. Now I'm going to go on to the next page. And then my last POE property of equality I have is division. And so again, if A is equal to B, then if I divide them by the same thing, such as C, those would also be equal. So this is like in algebra when you're solving equations and what you do to one side you have to do to the other. That is because of these properties of equality. All right, and last but not least, we have simplify, which is just combining like terms. So if I had 7x plus x, those are like terms, and I could rewrite it as 8x. So that takes care of all of our properties that we will be using for our proofs today. Okay, so starting here with example number 1, remember, we have our given and what we're trying to prove, and we find those from our conditional statement. So I'm told here, if 7 is equal to A and 7 is equal to B, then A is equal to B. So remember, my given is what comes after the if. So given 7 is equal to A and 7 is equal to B, then my proving, what I'm trying to prove, A is equal to B. So this is what I'm trying to prove. So now, again, we are doing what are called two-column proofs now, and what I'm going to do is put my statement, what I'm saying, I can assume, what I can prove, and I'm going to give my reason, what property I can use to verify that I can do that according to our laws of math. So starting here, at the very first spot, I'm going to say that A is equal to 7 and B is equal to 7. And remember, what I was given was 7 is equal to A and 7 is equal to B. But I flipped them, and that is because of the symmetric property. So symmetric. So I can say A is equal to 7 and B is equal to 7. Then I can claim that 7 is equal to 7 because of the reflexive property. Anything is equal to itself. So then lastly, I can conclude that A is equal to B because of substitution. Because A is equal to 7 and B is equal to 7, I can substitute them into this equation here. And that will conclude example number 1. Okay. Let's move on to example number 2. If x over 4 is equal to 12, then x is equal to 48. So remember, my given comes after the if. So given x over 4 is equal to 12, I want to prove that x is equal to 48. So the first thing I'm going to write is what I'm given. I'm told x over 4 is equal to 12. And that's given. My reason is that I'm given this. So remember, if this was an algebraic expression that I was trying to solve, what would I have to do to get x by itself? Because I'm dividing by 4, I need to do my opposite operation. And so I would multiply on both sides, and I would get that x is equal to 48. And I solved this equation, and I proved that x is equal to 48 because of the multiplication property of equality. And that concludes example number 2. All right, moving on to example number 3. Solve and justify each step in a two-column proof. We've already been doing that, so we should be experts by now. If 3x plus 2 is equal to 23 minus 4x, then x is equal to 3. So remember, my given comes after the word if. So given that 3x plus 2 is equal to 23 minus 4x, I want to prove the word that comes after then, that x is equal to 3. And again, I'm just going to go through this step by step as if I was solving this algebraic expression for x. So starting with 3x plus 2 is equal to 23 plus 4x. And my reason is that I'm given this. I'm told this from the get-go. It's given. Okay? So if I was going to be solving this expression, what I would do is subtract 2 from both sides because I want to get all my constants on one side and all my x's on the other side. So if I subtract 2 on this side, if I were to solve this over here, and I subtract 2 on both sides, that gives me that 3x is equal to 21 minus 4x. So that's going to be my second statement. And that's going to be because of my subtraction property of equality. Again, because I subtracted on both sides. So the next thing I want to do is move my 4x to the other side. So if I add 4x to both sides, I get that 7x is equal to 21. And my reason for this statement is the addition property of equality. All right, and then my last step to solve for x is going to be to divide by 7, and I get that x is equal to 3. And that's because of the division property of equality. All right, and I have already proved what I was asked, so I don't even need this last blank. All right, on to number 4. Solve for r if p times r plus 1 is equal to n. So I'm going to start with what I'm given. Now, again, if this were an algebraic expression that I was trying to solve, and I'm getting r by itself, what I need to do first is get rid of this p. And because it's being multiplied, in order to get rid of it, I need to divide on both sides. And I'm going to get that r plus 1 is equal to n over p because of the division property of equality. Okay. So now I have r plus 1 is equal to n over p. So what do I need to do next? I need to get rid of this 1, and I do that by subtracting on both sides. And I get that r is equal to n over p minus 1 because of the subtraction property of equality. And I have now solved for r, so I am done with example 4. I don't need this last space. Let's move on to number 5. Given 3 times 2x plus 2 equals 30, prove that x is equal to 4. So again, I'm going to start with what I'm given. And my reason is that it's given. And the first thing I need to do is divide this 3 on both sides. And I get that 2x plus 2 is equal to 10. And that would be because of the division property of equality. Next, I need to get rid of my constant, so I'm going to move 2 to the other side by subtracting. And I'll get that 2x is equal to 8. And that is the subtraction property of equality. And then my last step is going to be to divide again to solve for x, and I'll get that x is equal to 4. And again, that's because of my division property of equality. On to number 6. Given a times b plus 2 equals 45, and a is equal to 3, I want to prove that b is equal to 13. So I'm going to start with what I'm given. I can say this because it was given. I can also say that a is equal to 3 because that was given. So I can rewrite our original equation we're given as 3 times b plus 2 is equal to 45 because of the substitution property. And now I need to solve. I'm solving for b. Remember, I'm proving that b is equal to 13. So what I need to do first is move this 3, and I do that by dividing. So again, that's our division property of equality. Then I need to get rid of my 2, and I do that by subtracting. And I have now proven that b is equal to 13. All right, we are down to our final 2 here, starting with number 7, given 1/15 times x minus 2/3 t is equal to negative 2, and I want to prove that s is equal to 10t minus 30. So you'll have to really jog your memory back from algebra, because the first thing that we need to get rid of in order to solve this equation is to get rid of our fractions. So let's start with our first statement. I'm going to rewrite my equation I was given. Now, I need to find my least common multiple between my two denominators here, between 15 and 3. And my least common multiple is going to be 15. So I need to multiply my entire equation by 15 in order to solve. So that's going to give me 15 over 15s minus 30 over 3t is equal to negative 30. And now I want to simplify, and I'll get that s minus 10t is equal to negative 30. So I can say s minus 10t equals negative 30 because of the multiplication property of equality. And again, I'm solving for s, so I just need to move that t over, and I'll get that s is equal to 10t minus 30 because of the addition property of equality. And I am running out of time, so I will do number 8 on another video.